Hello guys, good afternoon to everyone. My name is Mohammed Sabir. In today's sessions, we are going to find the stress at a pressure cylinder problem. Basically, it is a gate PIQ problem. In this sessions, what basically we are doing, we are we basically will find the stress at a point which is at a distance 1 meter from a bottom. Basically, at this point, we will find the stress, axial and centrifugal stress. Okay. Uh, First, we will try to understand what is a system. System is such that basically we have a cylinder. Basically, we have a cylinder. It's filled with water having height of 2 meter. Okay. Now the now the question is that basically the question why we why we are going to find the stress, like, okay, because these axial stress and centrifugal stress is helpful to find the principal stresses, and by using principal stress we can find the uh, warm stresses. A warm stresses is important to design a pressure cylinder. Okay, well, when basically we can find the dimensions. Okay, like how much how much uh, should the dia of this body and that. Okay, we can calculate that things. Okay, now the thing is, now the we basically focus on to understand the system. We have this a pressure cylinder. Okay, before before moving to this problem, first we will try to understand the how to solve the uniform pressure cylinder problem. Okay, now we come to the this problem. Basically, here we have a cylinder having a uniform pressure P. Okay, having a cylinder having a uniform pressure P. And now the how we find the centrifugal pressure. You can say circumferential. You also can say circumferential pressure, circumferential stresses. The thing is that, like, this is a cylinder, like this is a cylinder, you can say this is cross sections, and this is a basically when we extrude up to this length, this is a cylinder. When we cut a sections dia along a dia, then we feel that this is the pressure profile, this is stress profile. How this cylinder will be in equilibrium? Okay, this is a problem. The sigma 2TL, sigma is stress at a circumferential region. Sigma 2TL is equal to PD into L. Okay, I think you understand what actually I am saying. By using this, you can find you get this circumferential stresses is PD by 2T. Okay, this is circumferential. When this cylinder, when we cut this cylinder along the along the periphery, then we get a axial stress. Then we get axial stress. The P is equal to pi d square by 4. You can say this is the pi d square by 4 into the pressure P, and this is how we equal this, like which force will balance this expressions. The sigma pi dt. Okay, the pi dt is what? The periphery. Okay, by using this we can get axial stress is PD by 40. Okay, this is a simple formula. It is simple derivation of the circumferential and axial stresses. This is PD by 2t and PD by 40. Okay, now we get this two pressure, PD by 14, PD by 2t. Okay, now the question, it's a little bit mistake is there. Basically here is a PD by 2t. Okay, you can correct it. Now the what the basic concept behind is, but in an actual problem, the pressure is varying because basically the cylinder is filled with the water. When we uh, go in a go in deep directions of a like when you go down in a cylinder, what basically we feel, the water pressure increases. So you can say this is a non-uniform pressure profile. How we find stresses at these conditions, this is the main questions. Okay, for what? For axial, for axial stress, basically we take a bottom pressures. We take a bottom pressure because how while deriving this formula, what actually we are assuming? We are assuming that how much pressure at a bottom level, how much pressure at a bottom level. For what? In a non-uniform case, we are assuming, we are basically trying to find out like how much pressure at a bottom level. By using this formula you can find that rho g into 2, because the cylinder, the height of the water is 2 meter. At the bottom the pressure will be rho g into 2 meter. So by using this you can find that axial pressure. Now, how to find the circumferential stresses? At a circumferential stresses, what pressure we put into that equation, that is what, because it is the special term. Basically we find that how much pressure at this point. This is what, like, our interest is to find a stress at a 1 meter from a bottom. Actually the pressure is the rho g into 1 meter. Okay, this is the basically the ultimate thing, the ultimate uh, approach to find the stress, axial and circumferential stresses. Okay, now we will come to the how we find the strain, axial strain in a x direction, how the cylinder expand. Okay, because well, like when we're going to design a something, our interest to find this, like, there's a pressure, the cylinder is filled with the water, like how much it deflects, how much it deviates from its original positions. By using this with a simple theory, axial stress is what, sigma x is equal to E minus mu, is the Poisson ratio, sigma y upon E minus mu sigma z upon E. Here here basically a 2D profile, so you can neglect the third coordinate, and by using this you can find the axial strain. By using this you can find the actual length after deformation. This is the main uh, reason behind to find the axial and circumferential stresses. Okay, thank you, all the best. Whatever question you have, you can ask freely.